The last problem we're going to perform from this section of the text kind of combines a bunch of things and even kind of taps back into what we talked about with Chapter 2 with nomenclature. So the problem reads as follows. Sodium and phosphorus react to form sodium phosphide. If 5.00 grams of sodium reacts with 4.00 grams of phosphorus, which in this case is P4, and the reaction goes to completion, what mass of which reactant is in excess? So first of all, we have to figure out what the limiting reactant is and what the excess reactant is. And in order to do that, we must first balance the chemical equation. So here we have sodium, and we're going to react that with phosphorus, which phosphorus exists in multiple forms. It's given in the problem here that it's P4, and this is going to give us sodium phosphide. Now remember that sodium has a +1 charge, and phosphorus, when it forms an anion, has a -3 charge, so our formula is going to be Na3P. So now we have to balance this particular equation. On the left hand side we have 4 phosphorus, on the right we only have 1, so we need a 4 in front of the product. That means we have 12 sodiums on the right, so we're going to need 12 sodiums over here on the left. So our balanced chemical equation is going to be 12Na plus P4 to give us 4Na3P. We're given the amount of each of the reactants that we have, so now we need to determine the limiting reactant. So we'll first start with 5.00 grams of sodium. We know from the periodic table that there are 23.0 grams of sodium in 1 mole of sodium. In the balanced chemical reaction, there are 12 moles of sodium for every 4 moles of Na3P. This is going to give us 0.0725 moles of Na3P, which is our product. Now we'll do the same calculation, but instead we'll start with 4.00 grams of the P4. From the periodic table, we know that 1 mole of P4 is going to be 123.9 grams. From the balanced chemical reaction, for every 1 mole of P4 that's consumed, 4 moles of Na3P are produced. When we do the calculation, we get 0.129 moles of Na3P. This tells us that the 0.0725 is the smallest number, so therefore the sodium is the limiting reactant. So this means that this is also going to tell us that P4 is the excess reactant. So we need to figure out how much P4 is going to react completely with 5.0 grams of the sodium. In this case, we know that 0.0725 moles of the sodium phosphide is produced. So we'll take that number, the 0.0725, which is going to be moles of Na3P, and we need to determine how much P4 it's going to take to produce that. So for every 4 moles of Na3P, we have 1 mole of P4, and that comes from the balanced chemical equation. 1 mole of P4, if we look on the periodic table, is 123.9 grams, which gives us 2.25 grams of P4. And again, we want to express this in a sentence. What is this 2.25 grams of P4, and what does it mean? We can say that if 5.0 grams of sodium is fully consumed, it will take 2.25 grams of P4 to complete the reaction. So this is the amount of P4 that is consumed in the reaction when all of the sodium reacts. So we're going to take our initial value, the 4.00 grams of the P4. We're going to subtract from that 2.25 grams of P4. That gives us 1.75 grams of P4. Okay, so this is our initial amount of P4. This is the amount that's consumed during our reaction, and this is the amount of excess remaining after the P4 reacts with 5.00 grams of sodium. So this value right here is the mass of the reactant that is left over after our reaction completes, and the excess reactant here is our phosphorus. So this is a long, lengthy example, but come exam time, I would expect you to be able to complete this without any type of a problem. So be sure you go over your notes, you know your stoichiometry, and don't forget the stuff from previous chapters, because it's going to creep up, and as we go through this course, we are going to keep building and building and building upon the foundation that we established in these first 3 chapters.